Hello, welcome to the BlueMed course for a healthy plastic-free Mediterranean Sea and building a sustainable blue economy in the basin, organized in the framework of the pilot action for healthy plastic-free Mediterranean. I am Erasmia Kastanidi from the Hellenic Center of Marine Research and the Knowledge Platform Coordinator of the BlueMed project. We are now in the third week of the course, which at the end of which will mark the finishing of the first part of the training. So this week you will see connections to the blue economy that will be the focus of the next parts sessions. And today we have the fifth lesson and the fourth webinar of our series, and which will be on the sustainable blue growth for a healthier and more productive Mediterranean Sea. Our speaker today is SeaFFava, who is a full professor of the Industrial and Environmental Biotechnology at the School of Engineering of the University of Bologna in Italy. And he has published about 170 papers on peer-reviewed international journals in the fields of bio-waste, biorefinery, blue biotechnology, and bioeconomy. And he has also coordinated a number of EU projects, Namaste, BioClean, the water for crops, among others. Among his many achievements, he is currently the Italian representative of the European Commission in Brussels in the Horizon 2020 Programming Committee for Food Security, Sustainable Agriculture, Forestry, Marine and Maritime and Inland Water Research and Bioeconomy, and the Italian representative in the Working Party on Biotechnology, Nanotechnology, and Converging Technologies at the OECD in Paris, as well as being the Italian delegate in the BlueMed Initiative group of senior officials. His talk will last about 45 minutes, and at the end you will be able to ask questions via the question tab on the webinar panel. Please use the allocated 15 minutes at the end of the talk to ask all your questions so that our presenter will not be disturbed. Also, just a few technical remarks regarding the whole of the course. You can find all the material from the previous webinars on the website, where we have also started uploading the material for the asynchronous lessons. The whole course will last until the 21st of July with our final webinar. But also please bear in mind that if you're interested in receiving a declaration of participation, you will need to follow the uploaded material as well. And if you want to interact with the teacher of these materials, you can also always use the comment section underneath each lesson. And on that note, I pass the floor now to Professor Favas for today's presentation.
Thank you very much for the kind introduction and for the invitation. I'm really very pleased to contribute to the e-training arranged by the BlueMed initiative. I think is a very important initiative that is the one of e-training, because we need to share things. We need to inform experts, but also other people, citizens in particular, about blue growth and what we are doing in order to have a healthier and more productive Mediterranean Sea. So it's very important to engage people and have them on board in this process that we are implementing. So thank you very much. I will, as you mentioned at the introduction, I will try to give you an overview on what we are doing in order to have a more sustainable blue growth in the Mediterranean Sea, and in particular what we are doing in order to mitigate the marine litter issue, which is strongly adversely affecting the productivity of the region. I will use my PowerPoint that will be then available for any of the participants, and so I go for the presentation of the PowerPoint. I hope that you can see it. So please confirm me that you are seeing my presentation.
Yes, we can see it.
Okay, so thanks a lot. Well, Blue growth. Blue growth is a very relevant issue. Sorry. Okay. So we are, with blue growth, we are referring to many marine, in particular maritime activities, like ship buildings, transportation, offshore renewable energy production, but also non-living resources exploitation, like minerals, for example, that we can also collect from the deep part of the sea. But then we have also the exploitation of living resources through aquaculture, through fishery, but also the exploitation, recovery, and then exploitation at the industrial level of the microbes coming from the sea, the so-called blue biotech. But then also tourism and many other activities that are run, that are exploited at the interface in between the sea and the land. In particular, for example, the agroforestry activities that we can have just at the interface in the coastal areas. So all of these activities altogether are making Europe 0.5 trillions of euro per year and 5.6 millions of jobs. These are data coming from the European Commission. In the Mediterranean, where we can also count on the non-European areas, non-European countries, the blue growth is making a gross marine product of 450 billion euros per year. This area, the Mediterranean, is making 20% of the global gross marine product, despite the fact that is representing only 1% of the total global water that we have in our planet. So 1% of global water, 20% of gross marine product. So Mediterranean area is, Mediterranean Sea is a very strategic sea. It's strategic for many reasons, many peculiarities. It is bringing a unique history. We know very well the many countries, many cultures are coming from Mediterranean first action initiatives. And in particular, we have in the area over than 400 UNESCO sites and 236 marine protected areas. So biodiversity is also rich and particular. But as I mentioned it to you, it is also an area in which a lot of maritime activities are on place, and sometimes they are not so sustainable. Maritime traffic, you see the numbers. The quite intensive coastal and maritime tourism that we have in the area, but also overfishing, overexploitation of local aquacultures. Many oil and gas plants are hosted in the Mediterranean area. This, of course, is creating opportunities, the numbers that I mentioned earlier, but also some challenges, geo-social political challenges that are affecting the safety and security of the area. The area is also under threat due to the climate change, which is quite heavy in the area, but also other coastal pressure that I mentioned already, but pollution in particular. In particular, the pollution due to plastics. We have a lot of plastic in the Mediterranean Sea. Mediterranean Sea is 1% of the global water, but is bringing about 70% of the global plastics that we have around in the water systems. We have plastic 4 times higher in amount with respect to the one that we have in the Atlantic Ocean, as an example. And this is due to the fact that the Mediterranean Sea is a semi-closed basin with a lot of industrial activities inside, the marine traffic, for example, the tourism, as I mentioned it to you, and a lot of inhabitants on place. They, of course, are contributing, as you will see later, to the release of plastics in the marine ecosystem. And then large rivers, Rhone, but also Nile and Po, are feeding the Mediterranean Sea by introducing in the sea plastics coming from the lands. The plastics that we are talking about, that you can see in the picture, are poorly degradable, poorly biodegradable in the sea where they has been released. So they are persisting in the Mediterranean Sea by strongly adversely affecting the health of the Mediterranean Sea and the productivity of the Mediterranean Sea. About the poor biodegradability of the plastics, I can provide you information coming from one FP7 projects funded by the European Commission in the last period of FP7 period, the last years of the FP7 period, one of the last projects funded by FP7 that I coordinated as a European coordinator. This project, BioClean, was addressed to understand if we could, if we can have sustainable methods, so sustainable technologies, in particular biotechnologies for disposing and also valorizing plastic wastes that we are accumulating at the land level everywhere in Europe. This project was joined by 19 partners coming from many countries in Europe, as you can see. One of the partners came from China, helping us in doing particular tests that we couldn't do here in Europe. There were 7 companies with us, 2 industrial associations that helped us a lot in this exercise. So the idea was to understand if we can have sustainable ways to dispose and also valorize to provide a value to the plastic waste that we are accumulating in Europe. We are accumulating about 35 millions of tons of plastic waste per year. 40% is recycled, 30% is burned for producing energy, 30%, the rest is collected in landfills, where they can undergo to photo degradation in some cases, degradation, gradual degradation in other cases, by producing small fragments, which together with plasticizers, plastics additives that are released from the plastics, can enter gradually the, the environment and gradually the water system, so the marine environment, where they can gradually enter the food chain where they can exert toxic effects. The European Union is producing more or less 1/4 of the overall worldwide production of plastics, which is about 340 millions of tons per year, but is responsible for the production of 75% of the most prominent, the most used petroleum-based plastics: polyethylene, polypropylene, polyvinyl chloride, and polystyrene. So European Union, European Commission was in some ways interested in understanding how take care to the waste coming from the use of such a large volume of plastics that they are producing extensively. This was the idea why they launched this call for proposals, because we really need a European level solution for disposing in an efficient way the plastics that we are accumulating at the terrestrial level every day in our activities, but also the opportunity to understand if we can accelerate the biodegradation of plastics that already enter the environment, the soil, but also the aquatic systems. These were the needs. And on these needs, the Commission launched the call for proposal. And we answered to the call with the proposal BioClean, in which we propose to develop innovative but also pilot scale and field scale validated biotechnological solutions for degrading and valorizing possibly the plastic wastes that we have in landfills, in terrestrial and aquatic environment, but also to enhance the biodegradation of these plastics wastes in the different habitats where they has been already released. This was the main objective that we planned for our project. So to do that, we of course looked at robust and active microbes coming from the environment, bacteria, aerobic, anaerobic, pure culture, mixed culture, but also fungi coming from the environment with the activity to degrade the most produced plastics, the plastics that we are mainly producing in Europe. So polyethylene, polypropylene, polyvinyl chloride, and polystyrene. We focus our attention on these plastics, and we selected microbes able to degrade those compounds, natural occurring microbes, not GMOs, genetically modified, but natural microbes, because the idea was also to add them in the environment where we could intensify biodegradation of plastics. We, of course, collected microbes also from collections, public collections around the world where microbe with specific degradation capabilities has been placed, made available to anyone interested in using them. So we look at for such a large number of microbes with the idea to produce biotech processes or integrated physicochemical and biotech processes able to degrade and depolymerize such plastics, but also with the idea to use this microbe for intensifying, as I mentioned earlier, the biodegradation of plastics already in soil, in the marine habitats, but also those persisting in composting facilities or in anaerobic digestion facilities where we are disposing normally organic waste. Very often there we have organic waste with plastics inside. So the idea was also to understand if we could intensify the biodegradation, the removal of plastics in those habitats. So we focus again our attention on the 4 different types of plastics for the reason that I mentioned it, that is recalled there, 70% of the production is coming from Europe. And we started looking at the microbes by starting from plastics, plastic wastes released already years ago in the environment. We went in landfills to collect plastic samples historically there. We went in composting plants to collect plastics that are persisting in the composting piles. In the anaerobic digesters, plastics persisting in them, or in plastic producing plants. We went around collecting plastics in the soil all around. And then we collected plastic samples, plastic waste samples inside the agency and the Norwegian Sea through some of the partners of the project that collected plastics from the seas, the 2 seas, very different seas. Why this? Because the idea was to look at new microbes, microbes that are coexisting with historically with the plastics released into the environment. Therefore, microbes that could evolve enzymes, so genes and therefore enzymes able to depolymerize the plastics on which they are growing. So for years, they could evolve, produce new enzymes. So evolve new biodegradation capabilities. So we were looking for those microbes, strong microbes coming from the environment that evolve with the strong metabolic activity towards plastics. This was the idea. And we started from a large number of different plastic waste collected from, as I mentioned here, many different habitats for obtaining a large volume of microbes. Indeed, we obtained more than 1,000 cultures, bacteria, aerobic, anaerobic, fungi, consortia of microbes all together, but only 16 of them displayed significant biodegradation capability towards the films, industrial films of polypropylene, polyethylene, polystyrene, and PVC. On PVC, we saw very interesting results, but on the others, the other plastics, we observed a very limited biodegradation measured through weight losses, but also through CO2 evolution. CO2 is the final product of biodegradation of plastics. So a limited biodegradability. But on PVC, we got interesting results, and we worked closely to this polymer. We isolated 2 or 3 pure culture Pseudomonas species, so Pseudomonas, different species of Pseudomonas genus, aerobic microbes, and we tested all of them for their capability of degrading films of PVC in polyvinyl chloride in a dedicated bioreactor, 15-liter bioreactor that you can see there. Under this condition, we observed the decrease of weight of the PVC film above 20%, 22, 23%, with the microbes, the specialized microbes. Without the microbe, we could have a 6% of reduction of the plastic. So about 18% of the mass could be degraded by the microbe. And this was very interesting results. Then we try to understand why that results, and then we realized later that the microbe, yes, degraded significantly, remarkably, the polymer, but by removing mainly the additives that are occurring in the plastics, by producing, therefore, the polymer, the PVC polymer, without the additive that has been added before preparing the film on which we work on. So our microbe was very active in removing the additive, but not the polymer, which was about 70% of the mass of the film. The polymer persisted, and the microbe cleaned up the polymer. As you can see in this plate, you have the polymer without the additive. The idea was great. Maybe we can reuse this polymer for preparing, once again, PVC films. So this could be a way to reuse the PVC plastics. Together with the PVC polymer without additive, we also, of course, obtained bacterial biomass with enzymes, with biomolecules inside. And we are still working on this now for understanding if we can recycle the PVC polymer for making new plastics, but also how we can exploit the enzymes, the biomolecule produced by the cells. Because if these ways are interesting, are sustainable and economical point of view, we can also put in place a large-scale treatment for degrading the PVC film waste and getting back PVC polymer to be reused, and of course biomass and biological resources to be exploited. But the other plastics were poorly biodegradable, really very, very poorly biodegradable. So we decided to understand if we could improve the biodegradability, the depolymerization potential of our microbes by pre-treating those plastics with gamma ray treatment, with a thermal treatment, with ozone treatment, but also a combination of ozone UV treatment that we also scaled up on the pilot scale for providing more plastics, pre-treated plastics on which we could work on. We observed that the treatment, in particular the ozone plus UV treatment, uh, decreased remarkably the molecular weight of the films by also improving its water solubility. These two info were very, very positive for us, because decreased molecular weight means depolymerize the structure, making it less uh, crystalline, so more amenable to the enzymatic activity, the enzymatic attacks. And also the improvement of water solubility is very important, because this can improve the bioavailability of the molecules. But despite of this, the biodegradation of the pre-treated plastics was still very, very poor, measured as a CO2 evolution, but was very, very poor. So those pre-treatment are changing remarkably the plastics, but not, uh, but this was not enough in some ways for improving the biodegradability, the biological depolymerization potential of the microbes. So we did the other exercise. Of course, I escaped many results, of course, and so I moved to the main results. So then I tested the other priority that we put on place. So the opportunity that our microbes could help the biodegradation of the plastics already in the composting treatment, in the anaerobic digestion treatment, in the sea. So we tested the potential of our microbes, those that display biodegradability potential, in a pilot scale composting facility, you will see there, in which organic matter was subjected to composting treatment. Plastics were introduced in it. So we tested with our microbes, in the presence of our microbes, for, understanding if our microbes could help the process. We did a similar exercise under anaerobic conditions by adding here the microbes that are suitable for anaerobic digestion, that we isolated to see if they could improve the biodegradability. And we did the similar exercise here in the lab, but then also in the full scale at the University of Crete, on marine water, actual marine water with plastics inside, with and without the microbes that we isolated in our project. And the results is, the overall results is our microbial addition, the microbes that we added didn't improve the biodegradation of polypropylene, polyethylene, polystyrene under composting and anaerobic digestion conditions. Didn't do it significantly, so with increase of 10%, for example. Of course, on PVC film, we observed interesting enhancing effect, due to the fact, once again, that the microbes are growing, consuming the additives. Under marine conditions, we observe some biodegradation activity on polystyrene, polyethylene, in addition to PVC, but only after 7 months. The removal of the mass depletion, the plastic depletion in mass was, as you can see, around 10%. So not so much, and in any case, after 7 months of exposure, so after a long time. Then we try to do other things, try to monitor the distribution of plastics all around the Crete island. You see the 4 cities on which we monitor the occurrence of plastics, how they were released, how they move in the water systems, and then we put together a number of recommendations on how we can reduce that problem. But let's go to the main message. The message was, okay, we provide a lot of new information. I mentioned only a few things for you, but the project was 3.5 years long and mobilized 19 partners. So we collected really a number of info. But the results is that, yes, we provide a lot of info, but the only plastic waste that, as a film, in addition, that we observe as a biodegradable is PVC. But this because it is containing a lot of additive. We can remove it. We can therefore produce uh, clean uh, polymer that we can reuse for making new films. But again, the only results convincing is on that we collect is on PVC. And then, of course, we work on the areas I mentioned it to you. But the main conclusion was we are not able to biodegrade significantly all the major polymer, all the major plastic types that we assessed in our study. So, in a, with the exception of PVC, as I mentioned to you. So the main message is we need to really go for selective recovery and recycling of the recovered plastics on the land, at the land level, for preventing that plastic is entering to the sea. And we have to facilitate as much as we can the gradual transition of the sector from the current plastics to biodegradable bioplastics. They cannot replace all the plastics, but where they can be used, we should go facilitate the use of biodegradable bioplastics. So given the particular recalcitrant of the conventional plastics, they are everywhere in our Mediterranean Sea. Here you have four graphs that are showing you different things. So the concentration of plastics on the first on the top, here on the left on the top, the occurrence of plastics, concentration of plastics on the different coasts, the Mediterranean, similar information in the other graph. Here on the bottom part on the left, you have basically the distribution of plastics in the water system, how the plastics are flotating. And here on the last graph, you have the, uh, the occurrence of turtles that ingested marine litter, so plastics. The occurrence of those turtles in all the Mediterranean area. So the problem is very relevant. European Commission ran a study on the type of plastics that are available in general in the Europe. The majority of plastics that are recovered in the marine habitats, European marine habitats, are due mainly to the single-use plastics and another very important amount of plastics occurring in the sea is due to fish ingest that are released inside the sea. So they are composing more or less 70% of the items that they are recovered in the European sea systems. And but of course you have also other kind of waste. But about the plastics, the most important are the so-called SAP and the fishing related plastic material. Let me add something about one initiative that is called BlueMed that we launched together, the European member states of the Mediterranean area in 2014 for sustaining through research and innovation more sustainable blue growth of the area. We started 2014, as I mentioned it to you, because it was clear the sheen that I presented you. So Mediterranean is an area that contributes remarkably to the European economy, but it is facing relevant environmental challenges that I mentioned earlier, and it also has to start exploiting in a more efficient way biodiversity, deep sea resources, for example. So a number of challenges, a number of new opportunities to exploit in a very strategic environment. BlueMed was addressed to go in this direction, face the challenges, exploit the opportunities, but as a joint action among the member states, European member states of the area, because no one of these countries can do the same things alone. We need an alliance. We need a joint strategy, a joint research and innovation agenda. Currently, 16 countries are joining BlueMed initiative, also non-European member states that you can see in the list. So all member states of the area are working together. We together prepare a strategic agenda, so the research and innovation priorities for having a sustainable blue growth in the Mediterranean Sea. So a number of priorities addressed to better know the ecosystems, better know the biodiversity, the peculiarity, the resilience to natural anthropogenic pressures, but also the capability of those biosystems to adapt themselves to the climate change and other agents, other pressures. And then, of course, how we can grow bio-based industry, but in particular aquaculture, fishery, tourism, by taking into account the ecosystems in a way that these industrial activities can be more sustainable. And also how we can better exploit the maritime spatial space that we have, how we can manage the coastal zone in a more efficient way, in a more sustainable way, and also new techniques or new technologies or new approaches for a smarter, greener, more sustainable transportation, for observing the processes by combining the existing processes, the existing observing systems, but also the conversion of the platforms that we have in the Mediterranean area. We have many platforms, oil and gas platforms, that can be converted multi-purpose platforms, and then also cultural heritage. There are 7 European projects running, Horizon 2020 projects, for an overall of 43 million euros that the Commission put on the table for sustaining the research and innovation needs that we highlighted in our agenda, the agenda that you have in front. And then other projects are running there through Interreg system. BlueMed couldn't, of course, ignore the major problem that I mentioned to you earlier. So the extensive occurrence of plastics in the Mediterranean Sea. Therefore, the BlueMed governing board in 2016 decided to do something strong here jointly to reduce, mitigate the marine litter problems and to prevent, of course, the increase of other this phenomenon. This by following the approach that were already proposed by the European Commission for the mission on healthy sea and oceans. So all actors together for phasing, for reducing by an important percentage of the plastics in the Mediterranean Sea in due time. So the idea was to map what each country is doing internally for mitigating the problem of marine litter, and then bring together all this info, this experience, these technologies, bring together, share what is available in each country through a digital platform, and then develop together a joint action addressed to mitigate the problem in concrete, to a joint strategy, a joint agenda. The problem is quite complex. It's due to many phenomena. So what we are doing at the city level, the so-called metabolisms at the city. It is releasing plastics into the sea, but also dump sites. We have still in the Mediterranean area some open dump sites. So those dump sites has to be closed, of course, prevent that they are releasing plastics. And then we have the rivers. We mentioned this. We have maritime activities that are releasing plastics that are then degraded, fragmented, and are becoming microplastics that are entering in the food chain, as we mentioned. So to face the problem, we need to put in place an integrated approach. First of all, we need to better monitor the process. In some pieces, in some parts of the Mediterranean, we need to better understand the amount, the composition of plastics that are entering into the sea. And then, of course, we need to remove the plastics that are already on site, that are already in the sea, the huge amount of plastic that are already there. Those has to be removed. This can be done through the fishery system, so pelagic and benting throwers. This can be done also by removing plastics from the beach, from the beaches, but also removing plastic from the rivers that are introducing plastics into the sea. But then, very importantly, we have to develop strategies for valorizing the plastics that we are recovering from the sea. They can be burned for producing energy. They can be depolymerized for producing building blocks from which we can restart and producing new materials. It is important. This part is very important because if we are creating a value chain, we can have money for sustaining the cost of recovery of plastic from the sea. Here you have a long list of activities in progress addressed to valorize the recovered plastics. And then, of course, we need to prevent that new plastics are entering the sea. So we need to reinforce the selective recovery of plastic waste at the terrestrial level and the recycling of them. So circular economy on plastics. We need to close the dump sites in order to avoid that plastics is entering to the sea. We have to remove through filtration plastics that are moving to the sea through the rivers, through the highway and the urban runoff, and also the wastewater treatment plants. So we have to stop these plastics. And then we need to reduce the use of plastics, in particular of mono-use plastics, and reduce the plastics granules in products. And then we have to go, as I concluded, on BlueMed, the project on the biodegradation of plastics, so BioClean. We need to gradually adopt biodegradable bioplastics, in particular by starting from the plastic that we are using directly into the sea for fishing jars or other type of plastics. And then we know, of course, we need to have regulations, legislation, specific incentives, education, communication, and also joint actions. We need to bring countries together for facing the problem. This is what BlueMed is doing currently. 11 countries joining BlueMed mapped already at the national level the activities that they are running in order to mitigate the problems through technological approaches, regulations, etc. We classified all the activities under monitoring assessment activity as a prevention, recycling of plastics, waste, collection and valorization of the plastic coming from the sea, education, training, communication, policies, regulatory framework, and financing. Each country detected what, mapped what is running internally. It placed all the activities in these 5 different boxes. You can find the information available at the website. Now those info are shared by the member states. We are working together on the data made available. Very soon at the website that you can see there, CMED.eu, you will find all this information. And after the summer, we will start to work together to develop a portfolio of inter-country, multi-stakeholders, multi-level actions that can allow us all together to really provide actions and initiatives addressed to reduce the problem in the Mediterranean, reduce the amount of plastic inside, and facilitates the recovery of those already inside. But through a joint action that is facilitated by BlueMed. This is the website in which you will see very soon the hubs. So what each country which is participating in the BlueMed exercise is doing at the national level. You can easily see by clicking the different apps. Maybe I'm late, but let me say a few final things. The priorities that I described to you. So the reduction of plastics waste in the environment, in particular in the marine habitats, and the circularity in the use of plastic are key priorities of the new European Green Deal, which is started, which was launched, which is on place for making Europe carbon neutral by 2015. But the topics that we are treating are core topics for the European Green Deal. You can find these topics in this area among the priorities on biodiversity, reduction of chemicals in the environment, but also on the left part, dealing with the circular economy priorities. So many things will be done on that direction. So new legislation or revision of the existing legislations, but also investment, because we need the research and innovation to go in the direction that I mentioned it to you. Horizon Europe will allocate money for sustaining research and innovation in the new bioplastics, in the circular economy of plastics, and other the priority that I described through a couple of clusters, the two that you can find there, highlighted there, and also through the missions. One of the missions that Horizon 2020 launched is dedicated specifically on healthy oceans and seas, and also coastal and inland water. So all the Horizon Europe tools will take into account the needs that we have to reduce plastics in the Mediterranean Sea and to allow this strategic area to maintain its productivity and the hospitality that this area always offered to all of us. Thank you very much for your attention.
Thank you, Fabio. Thank you for the very interesting presentation. You are all welcome to start asking questions. We already have the first question. And the question says, on a global scale, the Mediterranean is the most plastic polluted sea? Within the Med, the concentration of plastic is different. In particular, I'd like to ask the condition of the Adriatic Sea. It seems to me to be a forgotten part of the Med.
Well, the contamination is everywhere in the Atlantic. In the Adriatic Sea, as in the other seas. When I talk about the Mediterranean, I'm referring to all the seas that we know that they are, of course, connected. The problem is everywhere, as I tried to show you in the 4 graphs at the beginning. So it's everywhere, more or less, even though the concentration of plastics, also the types of plastics are different. But the overall problem is remarkable. We have 4 times higher amount of plastics than in the Atlantic Ocean. So it's a very big problem. And the solutions can be found, should be identified all together. Now, we cannot see differences in the sea. They are all connected.
Indeed, it's a very big problem if we have such a big
Yeah,
concentration. It's because it's smaller sea.
and
Um,
semi-closed,
and
semi-closed.
semi-closed, yes, of course. So it is a big problem, a very high concentration. If you any more questions, if you'd like to ask anything else to Professor Fava, we still have some time. Otherwise, you can always write your questions in the comment section when we upload the material this afternoon. No, I think maybe it was very interesting, but I think people might want to watch it again because it was. Yes, if you'd like to say anything more yourself, please,
Well,
Fabio.
sorry, I went through many topics quickly in order to allow to have
Yeah,
time for the discussion. So I apologize if I've been too fast, but the material is there, is available there. What I want to say is that you will see very soon in the website that I mentioned to you what the different countries are doing uh, in the field. So it's very, very interesting because you can see um, full-scale monitoring initiatives. So areas like Adriatic Sea or the other seas monitored by 20 different boats that are working together. You can find interesting example of companies that are depolymerizing nylon, for example, for getting
so
monomer from which you can. So the main message is please go to the website that I mentioned. The new one is not yet available, but in few weeks it will be available to see how many different initiatives, how many different prominent projects are running in the different countries for facing the problem locally with the local specificities. So very impressive what the countries are doing. But again, we need to work together because any effort coming from one side, from one country, is not sufficient for phasing the overall project. So the idea is to share the best practices, to work together through a common share roadmap for facing the different parts of the Mediterranean, the problem, to really contribute in an effective way in few years to mitigate the marine litter problem.
yeah, you're absolutely right. One country cannot solve such this problem. We've had a couple more questions.
Yes.
One is, I think you partly replied it, I think, by what you were saying now, whether there are any efforts to control the production of plastics.
Well, this is a difficult issue because we need plastics. We can reduce the use of plastic for sure, but it's difficult to think about a world or our life without plastics. So we can reduce. We are pieces of so some sectors in which we can reduce the volume of plastics used for sure. We are areas in which we can replace conventional plastics much more recalcitrant, more persisting with biodegradable plastics. And so we have to work in these areas for facilitating the substitution. But again, here we need research and innovation, and the plastics biodegradable are not normally offering all the features that we want from the plastic. So it's a long process, but it is clear now that we have to reduce the and we have to collect and recycle efficiently the conventional plastics and then go gradually where we can with the biodegradable bioplastics. So the sheen is clear now, but the process complex will require a long-term cooperation and actions.
Another question that I think fits well is regarding the results that showed that the microbes were not successful enough in degrading plastics polymers. Have you investigated other ways to biodegrade the plastics?
Well, we tested all. We worked for 3.5 years in at least 9 different countries by sharing, using different approaches for degrading the 4 target plastics that we selected in BioClean. So we did our best. The results was the one that I mentioned to you. We have around still over than 1,000 microbes, novel, coming from open environment where plastic were historically there. So we have today, every day, we have some papers in which somebody isolated a new microbe which is degrading significantly uh, a new type of plastic or one of the conventional plastics. But the biodegradation is normally not so high, so rapid as we want, as we need, and often is specific on one type of plastic. And they often is very relevant under laboratory conditions that are not the real ones. They are not the real ones, the open environment, where the biodegradation processes are always slower. So the problem is still open, and it's difficult to see or to say that we have effective solutions for degrading biologically and also through chemical pathways the conventional plastics. On nylon 6 we can do. Nylon 6 is used for as a jar for making jars, so this plastic can be recovered, depolymerized chemically, and then repolymerized for producing other kind of plastics. But it's a particular case. It's one type of plastic that can also easily can be recovered from the sea in an efficient way. But this is very important, of course, but it's not a general scenario.
And I think we can ask one more question
Sure.
regarding again the bioplastic and if it is a real solution. Do we have any study of biodegradation rate in the marine environment? The faster degradation in smaller pieces, could that be a problem? It's especially for the animals.
And we are at the beginning here. We have already on the market compostable plastics. So plastics that can be bioplastics that can be biodegraded in composting facilities. So once we are disposing the material at the end of, so at the bags that we are using for collecting organic fractions, for example, they are compostable, they are biodegradable under composting conditions, which are particular, which are aerobic or mainly aerobic conditions. We have there a lot of microbes, bacteria, and also fungi, so particular microbial ecosystems. We have plastics that are biodegraded there efficiently. We are at the beginning on the biodegradation of, on the bioplastics biodegradation in the marine habitats. We have some preliminary results. And of course, fragmented plastics can be degraded more rapidly because of the high surface that they can offer to the interaction with microbes. But still, we need to clarify many things here because the marine habitats are different than the composting environments or the anaerobic digestion environments, because we have microflora very different. There are the bacteria and other growing in salty water. So the community, the microbial community are different from the other that we have at the terrestrial level. So we need to work here to test the biodegradability of the existing bioplastic biodegradable and at the terrestrial level, but also to develop bioplastics, other kind of bioplastics that can be more biodegradable underwater and the marine environment conditions.
Okay, we've been having a lot of questions coming now at the end.
I'm here, so after you.
We can try and send you the questions, and we can report them in the comment section underneath the web when we upload where we upload the material. Maybe another small answer regarding what can the students do. What it was, because I thought it was an interesting point that we can connect it to the rest of the work that we're doing. And yes, what can the students working on quantification of this plastic crisis on the beaches? Can we start using the bioplastic as a remedial solution?
As I mentioned it to you earlier, the bioplastics are already interesting because they are consisting of carbon coming from biomass. So at the end of the life, we mitigated the CO2 release if we are using bioplastics. Bioplastics are often biodegradable, but not all bioplastics are biodegradable. So the biodegradable bioplastics are the best that we might use for preventing, of course, the marine litter. But we need to make sure that they are biodegradable in the marine environment. And again, bioplastics, biodegradable, are particular plastics that cannot replace all the plastics that we have on place. We are using a large variety of plastics for doing fantastic things. We cannot live without plastics, without the conventional plastics. So we can replace part of them with biodegradable plastics, but we need to check that they are also biodegradable in the marine habitats. The very important point is to combine this innovation with the selective recovery and recycling of the conventional plastics for preventing that conventional plastics are entering the water systems and therefore the marine environment. The students can do a lot, contributing with fresh ideas in research and innovation, contributing informing citizens about the importance of go for circular economy in the plastic domain. So selective fraction, selective recovery of plastics and recycling. So they can do a lot. Also volunteer, they can be volunteering in the recovery of plastics on the beaches as an example, or also collecting samples for analysis. I have a lot of students running thesis on this in my labs.
Okay, thank you very much for this very informative talk, and thank you all for being here and following this webinar and the rest of the training. And as I said, any questions can still be asked in the comment section, and we will send them all to our presenter and get an answer for them. Thank you very much.
I will be very pleased to answer the additional questions coming by writing.
Thank you. Bye-bye.
Thank you very much. All the best.
You too.